Hello guys, so we are back again, and in this session we are going to study some problems on extension. Means we have extended the inequality am greater than equal to gm greater than equal to hm, okay, which was as follow: summation I is equals to 1 to n, okay, upon n. The second was summation pi, okay, pi ai, okay, the whole power 1 by n, where I is equals to 1 to n, okay. And the third was n upon summation 1 upon ai, where I is equals to 1 to n, okay. So these were three extended forms, okay, and of am greater than, this is nothing but just am greater than equal to gm is greater than equal to hm, okay. Okay, just these thing only, okay, just extended, okay. Many children get afraid of these things, okay. If you know sigma and pi, okay, since we have done so many lectures, okay, about 19 lectures, okay, on series and progressions and problem solving 10 lectures, okay. So it should not be a quite surprise for seeing this advanced form of, okay, am greater than inequality, am greater than gm greater than hm, okay. So what we are going to do, we are going to do problems on this. The first question which we are going to encounter is as follow: let a comma g and h be arithmetic, geometric and harmonic means respectively between three given positive numbers a comma b and c. Then prove that the equation having a comma b and c as its root is x cube minus 3ax square plus 3g cube by h minus g cube is equals to 0. Now they are telling that a, g and h are means okay, arithmetic, geometric and harmonic mean between two given positive numbers, okay, between three given positive numbers, okay. So what we can do, arithmetic means, okay, arithmetic means is what, total number a b c by 3, okay. And here since three number are there, okay, so their subscript will give n plus 1, okay. So that is the main thing. So here we got arithmetic mean, which is a, we are representing arithmetic mean by a, okay. Similarly geometric mean will be what, a b c by 1 by 3, which, okay, this is geometric mean, we are representing by g. We will move this 1 by 3 power here, which will become g cube is equals to abc, okay. So we got our g cube value, we have our a value, okay. Okay, we can get 3a value, 3a will be nothing but a plus b plus c, okay. So we got two things. Now h, okay, h will be what, 3 upon 1 by a, 1 by b and 1 by c, okay, which we can classify further, okay. Here it will become what, 3 abc will come in the top, finally ab plus bc plus ca, just AB and BA into AB. AB will move out, they will multiply with C, giving me finally ABC in the bottom, which will move upside, okay. So breaking up and doing it into two steps, okay, it's just a wastage of time, okay. So we got our H, okay. Now what our next thing is that to get 3a value we have ABC, okay. 3g cube by h value we want, okay, which is nothing but g cube value is what, abc into 3 upon, okay, h value is what, h value is 3 abc, okay, upon what, ab plus bc plus ca, okay. This was in the bottom behind this, but it will move up, so this value will be nothing but this, and this will cancel out, giving me finally ab plus bc plus ca, okay. So we got this value also, and we already have this value. Now if I substitute the value x cube minus, okay, this is nothing but a plus b plus c into x square, and this value is nothing but ab plus bc plus ca, okay. There should be x, okay, sorry, x minus what, abc should be equal to 0. Now it is a cubic polynomial, and here it is what, sum of root, here what is sum of roots taken two at a time, okay. And the last, okay, is the product of the root, okay. So hope you have understand. Okay, so from here we can clearly say that A, B, C are the roots. Okay, that is what we wanted to prove. Okay, because if the sum is given, there this is given, and the product is, means A, B, C are the roots. Okay, and this is the last, is the product of the roots, which surely confirms that they are the root. Okay, now let's move on to the next problem. The next problem is this problem, okay, which says let a1 comma a2 comma a3 until an be positive real numbers in geometric progression for each n. Let an comma gn and hn be respectively arithmetic mean, geometric mean, and harmonic mean of a1, a2, and so on till an. Find an expression for geometric mean of g1, g2 till gn. Okay, in the terms of a1, a2 till an, comma h1, h2, hn. Okay, so the relation which we have between geometric mean is g square is equals to ah. Okay, we have already studied this relation in progression and series, progression and series. Okay, we have studied this relation. Okay, I have derived this relation. Okay, but you just need to remember this relation. There is no need of the derivation of these things. Okay, so just keep in mind, just you know this thing. Okay, so you got that, you know that the expression which relates a and h will be nothing but this relation. Okay, but for that what I need to find is that arithmetic mean and harmonic mean and geometric mean of this a1, a2 till an, a1, a2, a3, and till what, an. Okay, so if they are in gp, okay, they are telling that they are in geometric progression, they are in gp. Okay, they are in gp. Okay, geometric progression. What that means, that I can write this as a, this as ar, this as ar square. So what will be my last one? Use the tn formula. Tn is equals to ar power n minus 1. So ar power n minus 1. Okay, so we got this thing. Now we want geometric mean of these terms. So my geometric mean of these terms will be what? A into a1 into a2 into a3 till what? a n minus 1. And here are n terms, so 1 by n. Okay, 1 by n. Okay, we should, here n is already present. Okay, and using it for n terms again is problematic, so we will use here m. Okay, so here there are m terms. Okay, 1 2 3 till it is nothing but just m terms only, n terms only, but we are writing it m. Okay, because we have already used n here. Okay, so what we came to know that here, okay, when we open it, there will be, okay, we will use here m. Okay, when we open this, there will be a r power n minus 1. Okay, r power n, there will be n, and here we don't want to have one more n, so it will create confusion, so we are using m. So total m terms are there. Okay, so what we can do, okay, there are, okay, and if I just multiply the a, okay, what a I get, I can get a as, I will get a as a power m. Here all will be a till m times, and here r will be what? How many times will be r? R will be like this, r 1 2 3 till what? M minus 1 times, n minus 1 times, sorry. Okay, m n minus 1 times. Okay, so we will use m here also. Okay, we will use m only. Okay, in each and every place. So here m minus 1 times will be r. Okay, how this equation came, let me tell you, otherwise you will be confused. ar square, and so on till ar power n minus 1. A will be n times, so a power, which we are using m, and here r we add 1 plus 2 plus 3 plus, okay, the last will be m minus 1. Okay, so through that this equation came the whole power 1 by m. If this 1 by m power goes to this, I have a. If this power, okay, this is sum of m minus 1 term, which is nothing, m minus 1 into m minus 1 plus 1 upon 2 by 1 by m. Okay, so now from where this came, this is nothing but sum of n term formula. Okay, this is sum of n term formula, which is nothing but n into n plus 1. But when I need it for n minus 1 term sum, I just replace n by n minus 1, which give me n minus 1 into n minus 1 plus 1 by 2. Okay, this is n into n minus 1 by 2, sorry. Okay, so if I replace this, what I have, a r power m minus 1 upon m upon 2, and here since 1 by 2, so 1 by m will be multiplied with this, giving me finally a r power m minus 1 by 2. Okay, so this is gm. Okay, so this is our gm. Okay, Now what we need to find is arithmetic mean and harmonic mean. Okay, let me get the next page. Okay, so for arithmetic mean, what we can do, okay, let's solve for arithmetic mean. Since there are a1, a2, a3 till what, a m term, okay, upon divided by m times. Okay, so if I substitute ar square and so on till ar power m minus 1 by m, what I get, I can take a common, 1 plus r square and so on till r power m minus 1 upon m. So this, don't you think that this is forming a GP with common ratio r and terms are, and there are m terms? Okay, so what we will get will be as follow. We will write here a r power m minus 1 upon r minus 1, and here it will be nothing but, okay, this is what, and upon m. Okay, so this is one thing, and this is our arithmetic mean, which we will call as b. Okay, we have our geometric mean only also. Now for harmonic mean, what we can do is that there will be m terms, top upon 1 upon a1, 1 upon a2, 1 upon a3, and so on till what, a, okay, a m minus 1. Okay, it will be, sorry, m term, which will give me finally, if I open, then I will have that a 1 upon ar and so on till what, a r power m minus 1, right? So I will move the a that side, which will give me a m upon what, this will be nothing but, okay, this will be nothing but, okay, this will be a GP in 1 by r. Okay, this will be nothing but a GP. Okay, let me write the denominator, which will nothing but 1 plus 1 by r plus 1 by r square and so on till 1 by r power m minus 1. Don't you think it will be a GP in this format? Okay, so if this is a GP, so we can write, okay, its sum very easily. Okay, and since it is 1 by r, so we will write it like this, 1 minus 1 by r power, how many terms are there, m, upon, I will write here what, 1 minus 1 by r. Okay, so what it will become, it will become like this, which will be nothing but a into m upon, okay, r power m minus 1, r power m, r minus 1, okay, upon, this is, okay, this will be r m minus 1, okay, which will move up, okay, and this whole thing will move up, okay, and which will give me, okay, which will give me, here it is r, here it is m. Okay, so what we can get, okay, I know it is quite complicated, okay, not easy, okay, not that much easy. When I move this here, I already have m, this whole thing will move here, m minus 1 into r minus 1 upon r power m minus 1. Okay, now let's just think, when I multiply, is there any chance for this term to cancel out? No. So what we can do, okay, let's leave it as only. Okay, so okay, now we have our am, we have gm, we have hm, we have. Now let's apply the condition g square is equals to ah, okay, which gives us what, this will be nothing but a1, a2, okay, there will be an means, and this will be h1, h2 till hn harmonic means, and this will be g1, g2, okay, g1, g2 until so on till gn. Okay, now we will move this 2 power here, which will give me 1 by 2. So here what we have, okay, here geometric mean is nothing but, let me, okay, get the geometric mean which we calculated, a r power m minus 1 by 2. Okay, this is the geometric mean, and here what we have, arithmetic mean of this, which was nothing but, what was the arithmetic mean, okay, we created, it was a r power m minus 1 upon m into r minus 1, and here this was what, harmonic mean, which was, okay, this is in the top, a m r power m minus 1 into r minus 1 upon r power m minus 1. So you can clearly see this will cancel out, giving me finally this thing, a square r power m minus 1. Okay, and here since there is 1 by 2 power, so when we move this power to this, we will get a r power m minus 1 by 2, which proves that this is gm and this is equal to a dot h power 1 by 2, hence proved. Okay, this was a theoretical question. Okay, but every question will increase your knowledge. Okay, a way of approaching the problems. Okay, the more question you do, the better you become in this chapter. Now let's move on to the next question. Okay, the next question is, okay, let me get the page. Okay, this is the next question, which is the third question. If a plus b plus c, okay, if a plus b plus c is equals to 1, okay, then prove that 8 by 27 abc greater than 1 by a minus 1 into 1 by b minus 1 into 1 by c minus 1. Whenever 1 by c like terms comes, okay, and they are in subtraction, okay, try to just multiply them. Okay, because if you multiply them, a upon 27 abc, okay, if I multiply them, what I have, 1 minus a upon a, 1 minus b upon b, okay, 1 minus c upon c, which gives me greater than. So now we are getting hint, we should multiply throughout by abc. Okay, if I multiply, my things will become less complicated. It will be just 1 minus a, 1 minus b, 1 minus c greater than 8 abc. Okay, so now I clearly am very obvious that here I should apply am greater than equal to gm. Okay, and here, okay, here what we should do, okay, here what we should do, that I am quite confused. Okay, still, okay, so okay, I still need to think, okay, what approach we should take, okay, to solve this one. Okay, so what we can do, okay, this one let's try. Okay, because here in multiplication only the terms cancel out, okay, and become 0. Okay, in hm such condition is not possible, so we will try am only, am greater than equal to gm, and here it is very obvious we should apply am greater than equal to gm. Now let's apply. What term we should use? 1 by a, 1 minus b, 1 minus c. Okay, in this one, okay, in this one. Okay, if I use this, okay, in while targeting this one, okay, 1 minus a plus 1 minus b plus 1 minus c upon what, 3 greater than equal to what, 1 minus a into 1 minus b into 1 minus c, the whole power 1 by 3, right? Now this is what, 3 minus a plus b plus c upon what, 3 greater than equal to what, 1 minus a, 1 minus b, 1 minus c. Now you can see we are going to the right way. So here 1 we will substitute here, which will give me 2 by 3. 2 by 3, the power 3 will be greater than equal to 1 by a, 1 minus b, 1 minus c. Okay, so we got this thing, which will be nothing but 8 by 27 greater than equal to 1 minus a, 1 minus b, 1 minus c. So we have proved one thing. Okay, now in the second thing, what we should do, okay, is quite means we should apply am greater than equal to gm, but there is no means, there is not a proper way. Okay, I'm not, if we multiply we will get 1 minus a. Okay, there will be 3 1 terms, okay, which is quite a problem. Okay, that's why I'm still confused. Okay, what we should do, okay, what we can do, if we do double terms, okay, if we multiply, I will be stuck. Okay, because, okay, if I multiply, I have 1 minus ab, okay, plus ab plus bc plus c, like that term will come. Okay, so what term I should target, that is quite a problem. Okay, so what we should do, let me think what we should do. Okay, if I take 2 terms, 1 by 2 power will appear. Okay, and 2 term means 1 by 2. Okay, which will, okay, here here 8 power will appear if I take two terms twice. Okay, so okay, so what we will do, we will apply, okay, we will apply am greater than equal to gm on taking two terms. Okay, taking two terms, okay, because we want to create 8. Okay, so like this, a plus, if I take, okay, a comma b, it will be like a plus b by 2 greater than equal to what, ab by 1 by 2, first thing. Similarly we will do for b plus c by 2 greater than equal to bc by 1 by 2. Keep it as 2. C plus a by 2, keep it greater than equal to ca by 1 by 2. This will be what, 3. Now what we can do, what we should do, if I multiply them, okay, can we get this thing, can we get this a plus b, okay, like that stuff. Okay, I'm not thinking that we will get something like that. Okay, now let's multiply a plus b into b minus b plus c into c plus a. Okay, what we have here, 8 greater than equal to ab into bc into ca power 1 by, okay, 1 by 2, the whole power will become same. Okay, now this is nothing but twice. Okay, this will be nothing but in the end the whole square, which will cancel out and give me finally this thing only. So what we are left with is this thing, a plus b plus a plus b into b plus c, okay, is greater than equal to abc. Okay, so we are getting this thing. Okay, so what we should do, what we can do, here we are getting 8. Okay, so what we can do, we are stuck here. Okay, if I multiply here, I am left with b plus c into c plus a greater than equal to 8 times abc. Is there any information? Okay, yes, a plus b plus c is equals to 1 is given, so we can write a plus b as 1 minus c and b plus c as 1 minus a and c plus a is 1 minus b greater than equal to 8 abc. Okay, how we write a plus b plus c is equals to 1, so if I keep a plus b here, then this I can write. Similarly goes for all b plus c and c plus a. Okay, so here by using this relation 1 and using this 2 from 1 and 2, okay, hence proved. Okay, so hope you have understand this problem, okay, and try to solve it by yourself. Okay, the last part I was stuck because it was quite difficult to predict. Okay, so now let's move on to the next problem. The next problem is, this is the next problem. Okay, if xy plus zx plus xy is equals to 12, okay, where x comma y comma z are positive values, find the greatest value of x y z. Okay, try it yourself. Okay, since they are asking the greatest value, so what we can do, we can apply am greater than equal to gm. Okay, the greatest value, okay, when they ask maximum value of any product, okay, x y z, apply am greater than equal to gm. And when they ask sum, a plus b plus c sum less than, okay, minimum value, try am greater than equal to gm. Okay, that is the biggest hit. Okay, so here they are asking the greatest value, so we will apply, okay, considering these terms only. So what we are going to get is xy plus zx plus xy the whole upon 3 greater than equal to what, x square, okay, z square y square upon 1 by 3. Okay, since we have multiplied these 3 terms, we will get this. Okay, it was very obvious. Now here if I substitute 12 by 3, it will be greater than equal to x square z square y square by 1 by 3. This will become 4. When I take 4 cube, it will be nothing but 64 greater than equal to x square y square z square. Okay, so what we can do, okay, what we can do when we move here, okay, this we can write as xyz, because we want that value. This will be 2 square. When I move it here, it will be under root 1 by 2 64 x square y square z square. Okay, what we can do, this will be nothing but under root 16 2, okay, this we can, okay, we can simplify it more effectively if I have done this. Okay, if I have moved here 4 1 by 3 by 2 by 3, okay, sorry, 3 by 2, then this will cancel out and here 8 will be left, xyz. Okay, how it happened, let me show you. It will become 2 square. I can write it 2 square, so 3 by 2, 2 will cancel out, then 2 cube, which will be nothing but 8. So we can substitute here 8. So our answer, greatest value, is nothing but, answer is what, 8. Answer is 8. So how was am greater than equal to gm? We got the minimum hint. Okay, then we applied considering these three terms. Okay, because x square y square z square will come. Okay, and there was no power terms also, so which was again more a hint that we should take this term only. Okay, and then we solved it. Now let's move on. So the next question is this. Okay, the next question is this. Wait, that was fourth question. Okay, this is the fifth question. Okay, so what this question is asking is that where n, okay, prove that 2 power n is greater than 1 plus n into under root 2 power n minus 1 for all n greater than 2, where n is a positive integer. Okay, so what we can do, we can do 1 minus 1 greater than n into under root 2 power n minus 1. Okay, so here, since here it is 1, so can I write it 2 power n minus 1 upon 2 minus 1 greater than n into 2 power n minus 1 by 2. Okay, now if you observe, this is a gp, this is a gp. Here a is what, 1. This is a gp, this is a gp. Okay, with r is equals to 2 and a is equals to 1. Okay, so, and if I do one thing, okay, this is 2 power n minus 1. Okay, so if I do, this is a gp, and this, if I multiply n into, okay, n into 2. Okay, so what we can do, this is a gp, that we are very sure. Okay, so 2 power this is a gp, 2 power 0 means 1, and the next series will be what? Okay, the next series, what we can do, okay, what we can do, this is a series, its first term is 1. Okay, 2 power 0, 2 power 1, 2 power 2, and 2 power 3, and so on till what is the last term, 2 power n minus 1. And here, if we take n here, we are left with 2 power n minus 1 by 2. Okay, so for this term, what we can do, we can write 2 power n minus 1 like this, that it is 2 into 2 power 2 power 2 into 2 power 2 into 2 power 3. If I place here 1, it will become 0, so 1 into 2 power 2, 2 power 3, 2 power 4, and till so on, what, 2 power n minus 1, the whole upon 1 by n. Don't you think like that? This, sorry, 1 upon n. Okay, so we can do this thing. Okay, so I can explain you this thing, how this came like this. Okay, 2 power 1, 2 power 2, 2 power 3 till what, n minus 1. Okay, and okay, the whole power 1 by 2. So what we can do, this will be n minus 1, so n minus 1 into n minus 1 plus 1 upon 2. Okay, and here it is what, here it is 1 by 2. Okay, if I take here, already 1 by 2 is there. Okay, here already, if I take here, I will be left with n, sorry, there is no need of this. If I take n minus 1 terms, 2 to the power till so on. If I take the sum of the top powers, it will be nothing but 2 power n minus 1, okay, into n by 2, okay. I'm doing some mistake. Okay, so let's try again, okay. First they have given us 2 power n greater than 1 plus n into under root 2 power n minus 1. What we did, we moved here n because here we can create 2 minus 1, n into under root 2 power n minus 1, okay. And this is a GP with a is equals to 1 and r is equals to 2, so we can form a GP 1 plus 2 plus, okay, and 2 square and 2 cube and 2, so till 2 power n minus 1 upon what, n, sorry, 1, okay. This is a GP. So what we can do here, we can represent this one as n into 2 power n minus 1 by 2. Now we have to prove that they are greater than, okay. Now if I consider these terms as, okay, these terms, and apply am greater than equal to gm on them, okay, then what I am left with 1 plus 2 plus 2 square plus 2 cube and so on till 2 power n minus 1 upon how many terms are there, n greater than equal to what, 1 into 2 square into 2 cube into so on till 2 power n minus 1, okay, power 1 by n, since n terms are there in gm. So this is 2 power n into n minus 1 by 2, the whole power 1 by n, okay. Addition of n minus 1 terms will be this, giving me n into n minus, okay, giving me n minus 1 by 2. Finally into n, this n will move on, and which will give me 1 plus 2 square plus 2 cube and so on till 2 power n minus 1, okay. So this is the sum of the okay, and this is the sum of n terms, okay, which is am. So from here we can clearly see that this is nothing but 2 power n minus 1, okay. So we can substitute, instead of this we can write here, and this is nothing but n into 2 power n minus 1 by 2, hence proved, okay. This was quite not a easy problem, okay, but sometime what happens, we get stuck at some things, okay. I was trying to manipulate here, but I was not able to get a hint to solve this. Then I thought, okay, these numbers are coming, let's try to apply m greater than gm on these numbers only, because I cannot, if I was able to simplify this thing, okay, then I would have proved that this is gm, and then I have then it would be very obvious that this is nothing but am greater than gm, okay. Now let's move on. Hope you have understand this process when we did it again, okay. Now let's move on to the next problem. The next problem is this, okay. And this inequality part is difficult part, because here, okay, the prediction that these terms we should take, and am greater than equal to gm and am greater than equal to hm will occur is quite a difficult task itself, okay, which comes after a rigorous practice, okay. Until you don't practice yourself, no teacher can teach you these topics, okay, inequalities, okay. And when you are when you start doing many problems on this topic, you will start feeling comfortable, okay. That it means some topics are like that until you don't solve yourself a large number of problems, you cannot get a grip on them, okay. So this is s, they are telling s is what, a1 plus a2 plus a3 till so on an. Ai belongs to r plus, for I is equals to 1, okay. I is equals to 1, then prove that this, okay, then prove that s upon s minus 1 plus s upon s minus a2 plus s upon s minus a3 and so on is greater than equal to n square upon n minus 1, okay. Here if I consider these terms, okay, when I reverse them, I can get some of these terms, okay, which gives me a hint that s can occur. So I will apply am greater than equal to gm, okay, hm. Listen why, okay, that's why I was telling that this thing comes after practice. What I noticed, that if I invert them, okay, my job will become easy. My denominator will become s, and this will be, all will be s added, okay, all s will be this, all s will be, okay, this all denominator will become first same ns, okay, minus a1 plus a2. I have taken minus common outside, and this will be what? A power n, and this is nothing but s, so n into s minus, okay, n into s minus s, okay, and at the top there will be nothing but n, and here it is s, so s will cancel out, giving me n upon n minus 1. Okay, so we are getting this. Okay, now let's apply. So s upon s minus a1, s upon s minus a2, s upon s minus a3, until so on, s upon s minus an, upon what? N greater than equal to, this is hm, which we just wrote, n upon, okay, n terms will be there. If I inverse this term, this will be s minus a1 upon s minus a2 upon s, and so on, s minus en upon s. So since bases are same, so we can write ns minus a1 plus a2 plus a3 and still an upon s. This s will move up, which will give me ns upon ns minus s. So here ss will cancel out, n into n minus 1, and this n will move here, which will give me s upon s minus a1 plus s upon s minus a2, and so on, s upon s minus an greater than equal to n square, okay, n square, okay, n square upon n minus 1. Okay, so hope you have understand each and every step. Okay, I tried my best to explain you. Okay, so the main thing is that you should be comfortable, okay, on taking the terms. Okay, s upon s minus, I should target these terms, okay, add on, okay, and then multiply here. Okay, that is also a task in itself. So when that, it depends upon your observation skill also, that if I invert them, okay, my s will become same. Okay, so this type of series becomes simplified if I take hm. Okay, now let's move on. Okay, where is the question number 7th? Let me get the question. Okay, so this is question number 7. Okay, which says as follow: if a1 plus a2 plus a3 and a4 until so on plus an is equals to 1, for all ai is greater than 0, I is equals to 1 2 3 till n, then find the maximum value of this. Okay, so they are asking the product maximum value, but always keep, okay, here power has come, so with the term which has power, we have to break it. How we have to break it? A upon the power divided by, okay, if there is 2, we will take it 2 times. Okay, the power divided by that number, how many times? So 2 times. Okay, break it in such a way that if I add this, I should get a1, and if I multiply this, I should get a square, provided there should be no, doesn't matter what constant power this is, like here it is 4, a1 square by 4, no matter how big power it is, doesn't matter, but it should be a square. Okay, that is the main aim, but while adding it should be perfect a1. Okay, no constant. Okay, no constant should be there, no constant should be there. Okay, these type of problem are very common. Okay, you will see create a b c cube value, a5 a7 b9 value, b power, find maximum value of this. Okay, these questions are very easy. They all just like here, if I tell you to find maximum value of this question or this question, what you will do? 5 a by 5 a by 5. Okay, you will consider these terms, a by 5 a by 5, how many times? 5 times. A by 7 a by 7 a by 7 a by 7 7 times, and similarly b by 9 b by 9 till what? b by 9 times. Okay, so this is the manner in which you consider terms. Okay, more often here, since one term power is there, so what we will do? Consider a1 by 2 a1 by 2. So if I do one thing, okay, if I apply, okay, here n terms are there, but a1 I broke it into 2 parts, a1 I broke it into 2 parts. So how many terms will be there? a1 by 2, a1 by 2, a2, and so on till an. I am applying am greater than equal to gm. Very obvious, since I want product maximum. Upon n terms were already there, but I broken this, so it will be n plus 1 greater than equal to, and here I will, when I multiply, I will have an by 2, a1 by 2, a2, and till so on till an, power what? 1 by n, n plus 1, sorry. So here this is what? a1 only, sum of n terms, it is 1 by n plus 1. Okay, its all values 1, and this one on add on will give me a1 only. So a1 till an will be 1 greater than equal to, this will be what? a1 square into a2, a3, an upon 1 by 4 power 1 upon n plus 1. So what we can do, okay, we can move this power here, which will give me 1 upon n plus 1, the power n plus 1 greater than, and here 4 will be multiplied, which will give me a1 square, a2, a3. So this is the maximum value of the product which is possible, which is nothing but 4 into 1 upon n plus 1, the power n plus 1. Okay, so hope you have understand this problem, how we approached it. Okay, these are the similar problems which can be asked. Okay, and we will encounter more of them when we go to institutional level questions. Okay, problem solving sets. Okay, we are going to do a lot of problems, okay, which will boost your confidence a lot. Okay, now let's move on. So the question number 8, okay, which we are going to encounter, okay, is this question. Okay, okay, if a comma b comma c are positive real numbers, then prove that a plus 1 the whole power 7, b plus 1 the whole power 7, c plus 1 the whole power 7 greater than 7 power 7, a raised to 4, b raised to 4, c raised to 4. Okay, now in this type of problem, when they give you such power, okay, power terms, okay, don't have a direct thought that okay, here they are not asking a maximum value of these terms. Okay, and this will not occur because they are not the variety which we discussed just a minute ago. Okay, they are different. Okay, they are asking them prove that. Okay, we have to prove that. So whenever these type of things appear, what you should do to consider terms, okay, v plus 1. Okay, these are the variety types. Okay, that is fixed approach that you should follow to solve this type of question. Okay, a4, b power 4, c power 4. Okay, now what you do, you should open this, and the terms which you get after opening, you have to consider them, okay, as your terms on which you are applying ap. Okay, so if I open, what terms I am getting? Okay, we are getting a plus b plus c, okay, ab plus bc, and c also plus abc, right? abc plus 1, okay, plus 1 also will be there. Okay, so these terms we are getting. Okay, so the power 7, okay, is good. Okay, so these terms we are getting after multiplying. So what we will do, we will apply am greater than equal to gm on them. Okay, these terms. Okay, these terms, how many terms are there? 3. Okay, 3 is 6. Okay, 7 terms are there. Okay, if we want to, okay, what we should do, here how many power? 1 2 3 4. Okay, 4 power. So what we will do, we will not consider this one. Okay, we want to create 7 in the denominator. Okay, to create that, we will consider this 3, these 3, and this one. Okay, this we will neglect this one. So we will apply amgm on these terms only. Okay, so a plus b plus c plus ab plus bc plus ca plus abc upon what? 7 greater than equal to what? A into b into c into ab into bc into ca into abc, the whole power 1 by 7, right? So what we are getting? We are getting something like, okay, this is nothing but, okay, we can write it a plus 1 into b plus 1 into c plus 1. Okay, upon, okay, here, okay, this is will 7. Okay, this will be 7. Okay, so we will move this 7 power here, which will give me a power 4, b power 4, c power 4 here. Now after this, you can do it by yourself also. This 7, b plus 1 power 7, c plus 1 power 7 greater than equal to, you can take any one condition, whichever you like, 7 by 7, a power 4, b power 4, c power 4. Okay, so we are done with this problem. Hope you have understand what we did. we consider the terms, okay, which they have given. Okay, we opened them, okay, and we neglected this, okay, this single term, okay. Okay, in some time you have to consider them all, but in some times you have to neglect this constant one. After considering, why we considered this only? Because we wanted to create 7, okay, 3 3 6 1 7. After creating 7, here will be 1 by 7 power, which will create this whole power 7, okay, which gives a power 4, b power 4, c power 4, okay. So hence we have proved this. Now let's move on to the next question. So the next question, okay, this is the next question, okay. So if prove that sec power 4 alpha upon tan power square beta is equals to sec power 4 beta sec power 4 beta upon tan square alpha is greater than equal to 8 if each term in the expansion expansion, you can cancel this expression, is well defined, okay. Okay, now if I call tan square alpha as x, while, okay, you can do this, okay. Trigonometry we have not studied till now, but when we will study, we will discuss these type of things are very easy in there, okay. We will study in very depth, okay. And tan square beta, if you call y, then automatically sec power 4 alpha will be what? X plus 1 the whole square, and sec power 4 beta will be what? Y plus 1 the whole square. Don't you agree with this? Now let's substitute the value. X plus 1 the whole square upon y square, y plus 1 the whole square upon x square, sorry, x, okay, x, okay, is greater, okay. So if we substitute these things, okay, then now what we are getting? We are getting x square plus 2x plus 1 upon y, and okay, just checking, okay, we have to prove this is greater than equal to this, okay, y square plus 2y plus 1 upon x. Okay, now what we will do, we will apply am, because we listen now, how we will create it. The way of creating it is the only possible way by considering 8 terms, and here 3 and here 3, okay. So 6 terms are only considerable. So what we will do, okay, we will try to break them, which is x square by y, 2x by y, 1 by y, y square by x, 2y by x, and 1 by x, okay. So the moment we break them, what we are getting? What we are getting, if we apply am greater than equal to gm on these terms, considering these terms, what we have? Okay, what we can have? X square, okay, here 6 terms are only there, okay, here 6 terms are only there, okay, but we want to create 8 terms, okay, and here 6 terms are only there. So what we can do, if we observe here x square, 2x by y, 1 by y, and 1 by x are there, right? So what we can do, okay, x by y, and here y by x, okay, here 2x by y are there and 2y by x. So can I write this 2x by y like this, x by y plus x by y, don't you think? And this 2y by x as y by x plus y by x. The moment I write, I have 8 terms. These 2 terms will break into 4, which will give me x by y, x by y plus x by y, y by x plus y by x, plus 2y by plus 1 by x, y square by x upon 8, greater than equal to, we have to multiply them, x square y into y by x into y by x into x by y into x by y, okay, and y square by x and 1 by x and 1 by y, the whole power 1 by 8. Okay, so here if you see, these two will cancel out with these two, this will cancel out with this, and 1y will cancel out. So all the terms will cancel out. Okay, and here 1 will be left. Okay, so what we are going to left with, it is nothing but this thing only. Okay, x square by y, okay, by 2x upon y plus 2y upon x plus 1 by x plus y square by x plus x by y, sorry, y square by x, okay, upon 1 by x plus 1 by y. Okay, and here it will move on this side, which will give me this. But wait a minute, this was nothing but this. So hence prove that sec power 4 alpha upon tan square beta, sec power 4 beta upon tan square alpha is greater than equal to 8. Okay, now let's move on. So so the next problem which we are going to do, okay, this problems means this problem, which is very simple question. 10th question, prove that n plus 1 by 2 by n is greater than n factorial. Okay, this thing is means taught in the classes. Okay, when they start this section, okay, they tell you that if you apply am, okay, so this thing is taught in classes. Okay, when they start this section, they tell you if you apply am on n terms, what will appear. So just remember these things. Okay, so apply am on natural number. So what will be 1 plus 2 plus 3 plus 4 plus upon n greater than 1 dot 2 dot 3 dot so on till n power 1 by n. This will be nothing but, can we take the sum of this n into n plus 1 by 2 into n greater than equal to n factorial upon 1 by n. If I move this here, I will, this and n will cancel out. I will have n plus 1 upon 2 power n greater than equal to n factorial. So this thing you should remember. Okay, remember, this is nothing but a knowledgeful thing. Okay, remember this sum of am greater than equal to gn on n natural number. Okay, this result is quite useful. Plus this is not a question, it is just a derivation. Okay, which you should remember. Okay, now let's move on. So the question number 11 which we are going to encounter, okay, this is the next question. Okay, here if a1 comma a2 and so on till an is greater than 0, then prove that. Okay, then prove that what, a1 by a2 plus a2 by a3 plus a3 by a4 and so on till an minus 1 upon an plus an upon a1 is greater than n. Okay, so here if I go in this order 1 2 3 and so on, okay, here since no zero term a0 is not there, it is n terms. Okay, so I will apply am greater than gm, because I will get automatically n here if I want to create n. Plus I can observe, if I multiply them, these terms are cancelling out if you observe all the terms. So if I consider these terms, I will have n in the denominator and n will move on. So applying am greater than equal to gm on a1 upon a2, a2 upon a3, a3 upon a4 and so on till an upon a1. See what we have, a1 upon a2, a2 upon a3, a3 upon a4, so on till an upon a1 greater than n greater than equal to a1, a2, a2, a3, a3, a4 till so on an upon a1. And here if you see, I have what, a n minus 1 upon an. This term will cancel out, this with this, this with this, and this with this, and so on. So here I will be the whole power 1 by n. Here my power will be 1. In the next step n will move here. So my proof is done. a1 upon a2 upon a2 upon a3, a3 upon a4 till so on till an upon a1 is nothing but greater than equal to n. Okay, so hence proof, there was nothing but just a application. Okay, just analyzing what term you should target in general. am greater than equal to gm greater than is equals to hm, greater than equal to hm. Now let's move on to the next question. Now the next question is this question. Okay, it is in triangle ABC prove that tan A plus tan B plus tan C is greater than or equals to 3 root 3 where A comma B comma C are acute angles, and this result is useful in trigonometry plus solution of triangles. Okay, so how we derive this result? Can I say, okay, acute angles, okay, in a triangle A B C, these are three acute angles, so A plus B plus C will surely be what? Pi 180 degree. Now if I do one thing, that A plus B I keep it here and move pi minus C I do, and take tan on both side. What I have? Tan A plus B tan pi minus C. So what I have? Tan A plus tan B 1 minus tan A tan B. Okay, formula you should, means I have not taught since trigonometry, so you just remember tan A plus tan B formula is tan A plus tan B upon 1 minus tan A into tan B, and tan pi minus C is minus tan C. Okay, which gives you what? Which gives you tan A plus tan B is equals to minus tan C plus tan A. I have cross multiplied it, tan A tan B tan C. If I move this that side, I am left with the result tan A plus tan B plus tan C is equals to tan A plus tan B plus tan C. Okay, remember it is true for acute angles. Sorry, it is in multiplication. Okay, so this result is true for acute angles. Okay, so always remember this. Okay, now if I apply, okay, both the results are important. Okay, this result is important in solution of triangle, plus it is also important, both the results are important for solution of triangle, and this result is important in both chapter. Okay, trigonometry and solution of triangles. Okay, now if I want to solve this, I will apply AM. Since I want some minimum, I will apply AM greater than equal to GM on tan A tan B tan C, giving me what? Tan A tan B tan C upon 3 greater than equal to tan A tan B dot tan C, which gives me tan A tan B tan C greater than equal to 3 times. But wait a minute, okay, it will be 1 by 3. I will move this that side, it will become cube, and this will become 27. This okay, sorry. So tan A tan B tan C. Okay, now let's move on to the next page. In the next page, this is very obvious, this will be tan A plus tan B plus tan C. Fine, power 3, and this will be 27, which will move here, which will become 27 tan A tan B tan C. Okay, now you remember this thing which we derived just. So can I write this thing as this? So if this is this, one power will reduce and this will become square, and this will cancel out, giving me finally tan A plus tan B plus tan C is greater than equal to, if I move square here, this will be 3 root 3. Okay, hence proved. Okay, this is a very good result. Okay, you should keep in mind. Okay, very great result. Okay, you should keep in mind. Now let's move on to the next question. Question number 13. Okay, which is this question? Okay, 13th. If n is greater than equal to 1 is a positive integer, then prove that 3 power n is greater than equal to 2 power n plus n into 6 power n minus 1 by 2. Okay, so what we are going to do you know this basic formula? A power n minus b power n is what? Okay, before doing that, tell me this. What? You will take a minus b, a plus b. In the next step, if I tell me this, you will tell a minus b, a square, ab plus b square. Now if I tell you and so on, if I go and tell you a n minus b power n, you will say this is a minus b. Okay, a minus b will be for sure. Okay, a power n minus 1 plus, okay, this power will keep on means increasing, means decreasing. Okay, and this will keep on increasing, n minus 3 b power 2 and so on. It will go on till what? A power, until a power becomes 0 and b power become n. Okay, so n minus 1, sorry, will become n minus 1. So this is the final result. Okay, so if you know this, then 3 power n minus 2 power n is greater than equal to n into 6 power n minus 1 by 2. Okay, so can I now do a basic? Okay, now I know that this is what? Okay, this is nothing but just an expansion. Okay, so what we can do is we can move it here, 3 power n minus 2. Okay, so we are getting this. Okay, which gives a hint that the term which we should predict is nothing but, okay, 3 minus 2 into 3 power n minus 1 plus 3 power, okay, 3 power, okay, the term which we should predict 3 power n minus 2 into 2 and so on. So we will predict this term and it will be what? 3 power 0 into 2 power n minus 1, last term 2 n minus 1. So if I consider apply am greater than equal to gm on this term, what I am left with? 3 power n minus 1, 3 power n minus 2, 3 power n minus 3. Okay, sorry, here it will be what? Here will be what? 2. Here will be 2 square and so on till 3 power 0 and 2 power n minus 1 plus upon how many terms? N greater than equal to, if I apply here, they all will, okay, 3 power n minus 1 and minus 2. Okay, this is nothing but n terms and this is nothing but, okay, this is 3 power n minus 1 plus n minus 2 and so on till 0. Similarly 2 power, okay, and 1 plus 2 plus 1 plus 2 plus till n minus 1, okay, upon 1 by n. So what we can do, okay, is we should apply what? N minus 1 till summation, which is nothing but 3 n minus 1 into n upon 2 into 2 power n into n minus 1 by 2 upon 1 by n, which gives us what? 3 power n minus 1 by 2 into 2 power n minus 1 by 2. Okay, so we are getting this thing. Okay, but wait, this is nothing but 3 power n minus 2 power n, and this is what we can write as 6 power n minus 1 by 2, and here it is n, so we will move it here, 3 power n minus 2 power n greater than equal to n into 6 power n minus 1 by 2. Hence we have proved this. So hope you have understand each and every step. First we generalize this. Okay, you should observe this. After observation we were able to predict what term we should take. The term when we consider and apply am greater than equal, we automatically got the result which they wanted to prove us. Okay, now let's move on to the next question, which is question number 14th. Okay, let me get the page. Okay, so this is the, okay, they want us to find the minimum value. Okay, so it is very obvious that we should apply am greater than equal to gm on this. Okay, so if I apply am greater than equal to gm, okay, what is, okay, this question is means very easy. Okay, there is no point in solving all this question. If a b c d is equals to 1, where a b c and d are positive real numbers, then find the minimum value of a square plus b square plus c square plus d square plus ab ac ad bc bd ac. Okay, so how many terms are there? 4, 5, 6, 7, 8, 9, 10. Okay, so total 10 terms are there. Okay, so what we can do is consider these terms only. Okay, okay, so when we consider these terms, what we going to have, okay, is there twice ab, twice ac? No. So if I apply am greater than equal to gm on these terms, okay, then what it is nothing but, okay, a square plus b square plus c square. This is what I want. AB plus AC plus AD, BC plus BD plus CD upon 10 greater than equal to A square B square C square D square AB AC AD BC BD CD. Okay, the whole power 1 by 10. Okay, the whole power 1 by 10, but this is nothing but 1. No matter what power it is always be 1. So A square, okay, it will be 1 power 1 by 10. So here we can get this value, which is some x value. We will call it as x. Okay, x value. Okay, and by 10, so x will be nothing but 10. So we got the minimum value. Maximum value can be infinite, but the minimum value will be 10. Okay, now let's move on to the next problem. Okay, so the assumption, okay, if you are able to predict that which term you should take, then your job is done. Okay, now the 15th question, okay, which is this question. Okay, if x comma y comma z and x plus y plus z equals to 1, then prove that 2x upon 1 minus x plus 2y upon 1 minus y plus 2z upon 1 minus z is equals to greater than equal to 3. Okay, so what we are going to do, okay, how we can predict the terms, okay, that is important. So what we should do, what term we should target here, x y z. Okay, prove that 1. Okay, if we modify this 2x upon, this is nothing but 1 minus x is nothing but y plus z, this is nothing but 1 minus y means x plus z, and this is nothing but 2z upon x plus y greater than equal to 3, right? So what we can do after this, okay, x upon two terms we can break on that. That is very obvious. Okay, that is nothing, means not a great thing. Okay, so what we can do, if I take 2 common, okay, then what we can do, what we can do, if I predict these terms, okay, so we want to create, okay, if I consider these denominator terms, if I cross multiply, then they will form 2x 2x 2y 2z. Okay, so let apply am greater than equal to gm on 1 upon x plus z, 1 upon y plus z, 1 upon z plus x. Okay, so 1 upon x plus z, y plus z, 1 upon z plus x, the whole upon 3 is greater than equal to what? They all will be multiplied. Okay, which will give us what? 1 upon, okay, this all will be multiplied x plus z into y plus z into z plus x. Okay, which will give us what? Okay, this will form, okay, this will form 2. Let's cross multiply and see what we are getting. Okay, then we will discuss. Okay, so what we can do is we are not able to get any term. Okay, if I multiply, then also we have stuck 2 terms are left. Okay, so what we can do, okay, so we are not able to get any result. So what we are going to do, let apply am greater than equal to hm. So here this thing is still same only. Upon 3, here will be 3 upon, okay, 3 upon what? It will be 3 upon x, 1 upon, okay, it is 1 upon, so they will be inverted, so which will give me x plus z plus y plus z plus z plus x. Okay, which will give me 3 upon 2x plus 2y plus 2z. So I will move this here, so I will have finally x plus y plus z here into 1 upon x plus z, y plus z, 1 upon z plus x multiplied by 9. And here if I multiply what I have, I will have what I'm getting 1 upon z upon x plus y, 1 x upon y plus z plus 1 plus 1 plus y upon z plus x greater than equal to 9. Okay, so here 2 is still there. Okay, so what we are going to do, okay, we are going to do is connect these three terms, 3 plus z upon x plus y, uh, x upon y plus z, y last y upon z plus x. Okay, so greater than equal to 9. So which if I multiply it by 2, okay, so now you can clearly see what the proof which we wanted. Okay, so the proof which we wanted to find, we can now get it. If I multiply by 2, this was the previous problem, it will be 6 plus 2z upon x plus y, 2y upon y plus z, 2x 2y z plus x, sorry, and 2x upon y plus z. Okay, is greater than equal to 9. If I move this, there will be 3 and 2z, x plus y I can write as 1 minus, okay, 1 minus z, 2y as 1 minus y, 2z 2x as 1 minus x greater than equal to 3. Okay, so this is our answer. Hope you have understand each and listen what I have meant, what I did. Okay, first I change this as using this thing. I came to know that if I take 1 upon x plus y and if I cross multiply, then I will get 2x. But here if I apply gm greater, then they will move here. Okay, and which will my problem will more increase. Okay, instead of simplifying. Okay, so what I thought, okay, since I was not able to reach to anything, I started applying am greater than. Then here it was means I should be more understand that if I invert these terms, okay, this will be 2z 2y, okay, 2xyz. Okay, so it was confirmed that am should be greater than equal to hm should be applied to prove this thing. After applying that, we moved this that side, we multiplied, we got this expression, we changed this and multiplied by 2, moved 6 there and got our answer. Okay, now let's move on to the next question. The next question is 16th question. Okay, which is this question. Okay, this is the general question, okay, of power. If a greater than 0, b greater than 0, c greater than a plus b plus c is equals to 6, then the maximum value of a square b dot c. Break a into power a by 2, b keep it as it is, c in 3 power c by 3, c by 3, c by 3. How many terms are there total? 3 plus 3 6. So apply am greater than equal to gm on them. Okay, on adding I am still getting 3, but on multiplying I'm getting c cube by constant, so that is the advantage. Okay, a square upon 4, b c cube by 27, the whole power 1 by 6. Okay, this is nothing but 6 by 6 greater than equal to a square b c cube upon 4 into 27 power 1 by 6. This will become 1. If I move 6 power, it will still be 1. So a square b c cube, this is the value which I want. And since it was working one, it was asking us a product value, so it was more obvious that we should, so 1 0, go for am greater than equal to gm c cube. Okay, so we got our answer, which is 108. Hope you have understand. Okay, this was just means a more explanation of the thing which I was asking earlier. Okay, that when such things are asked in power, okay, you have to break the terms as per the power. On the addition it should give a without any constant, but on the multiplication they should give a square with constant in product as multiple or by denominator, in the denominator or in the numerator. Okay, now let's. Okay, so the next problem is question number 17, which says if a comma b comma c are positive and a plus b plus c is equals to 1, then prove that 1 plus 1 upon a into 1 plus 1 upon b plus 1 plus 1 upon c is greater than equal to 64. Okay, so here in this problem, if I open this, what I'm getting, 1 plus 1 upon a plus 1 upon b plus 1 upon c. Okay, I'm opening this thing. plus 1 upon AB plus 1 upon AC plus 1 upon BC plus 1 upon ABC. Okay, if I consider them as equal to lambda something, okay, because this should lambda should be greater than equal to this. Okay, now if I consider these three terms and apply AM greater than equal to GM, what I'm getting is 1 upon A, 1 upon B, 1 upon C is greater than equal to by 3 is greater than equal to 1 upon ABC power 1 by 3. I will move it here, then what I have, A plus 1 upon B plus 1 upon C is greater than equal to 3 times 1 upon ABC power 1 by 3. Similarly, apply AM greater than equal to GM on these three terms, these three, what I have, 1 upon AB, 1 upon AC, 1 upon BC upon 3 greater than equal to what, 1 upon A square, B square, C square power how many terms, 1 by 3. Again we will move it that side, which will give me 3 into 1 upon A square, B square, C square by 1 by 3. Okay, this is 1 upon AB plus 1 upon AC plus 1 upon BC. Okay, so we got this sum value. Now we will consider these terms, which is A, B plus C by 3 is greater than equal to what, ABC power 1 by 3. But wait a minute, ABC is what, 1, so 1 by 3 is greater than equal to 1 upon ABC power 1 by 3. So we came to know that this value, okay, which is nothing but 1 upon 3 power 3, which is the value of 1 upon ABC. Now lambda is what, 1 plus this value, but wait, lambda is what, 1 plus this value. Instead of this I can substitute this value, which is nothing but 1 upon ABC power 2 by 3. And similarly, instead of this ABC I can substitute, this is 3, I can substitute 1 upon A, B, C. Okay, this was 1 by 3, this is what, 2 by 3, and here I can substitute 3 into 1 by 3 power 3. Okay, so we are getting this. Okay, so here, okay, I am substituting all the values, like in place of ABC I substituted this value, in the place 1 upon AB, 1 upon AC, 1 upon BC I substituted this value, 1 upon ABC I substituted this value. So what I am getting, what is 1 upon ABC? It is nothing but 1 by 3 means 3 power 3 by 3, 3 into this, what is 3? Okay, first you should know what is your ABC value. Okay, it is 1 by 3 power 3. If I substitute, this is nothing but 3 power into 2 by 3, and similarly this is what, 1 by 3 power 3. Okay, which gives you 1 plus, okay, 3 into 9 plus 1 by 27, which ends up, okay, it will give you some value, which is the value of lambda. Okay, 1 upon ABC, right? Okay, which is 21 upon 27. Okay, so we are getting 1 by 2. Okay, so this was our answer. First, what we did, we opened this, we got these three terms, we applied AMGM on this, AMGM on this, AMGM on this, got the maximum value. Okay, and then substitute this value here, and then got our answer. Okay, hope you have understand. So this was our lecture on problems on AM greater than equal to GM. Okay, and we will move on to the next lecture, and we will discuss weighted means, nth power means, and Cauchy inequalities. Okay, so till then, take care, bye.